Well, good morning, everybody. We're going to do, excuse me, we're going to do a short overview of starting and batteries and stuff. Now, next week we're going to do one on alternators and charging and that kind of thing. But to start with, you need to always wear safety glasses when you're working around a battery. I don't know how many times, and myself included, I've jumped off cars and been around batteries and all that kind of thing, and didn't have any eye protection on it at all. Now, most of the time nowadays I wear regular glasses, but wearing safety glasses or some kind of eye protection when you're working around a battery is really important. Back in 1978, I was working on a Dodge truck. Might have been 79, I don't remember, but anyway, it was a Dodge truck, and I was going to take the battery cable loose, and I took my wrench and I put it on the battery cable, the nut that was holding the battery cable terminal. You know, you got to loosen that up to get that loose. I made 1/4 of a turn, and I had my forearm in front of my face when that battery exploded. The last thing I expected was for that battery to explode. All that acid and all those pieces of plastic and everything hit me in the arm and didn't make it to my face, but I wasn't wearing safety glasses. So if you don't want an exploding battery to be the last thing you ever see, you need to wear eye protection when you're working on batteries. Don't ignore this. It's really important. Although people every day, mechanics and everybody else, will jump off cars and have jumper cables around, you know, with the potential of making a spark above a battery that's got explosive gas, you know, seeping out of it. I can't talk about that enough, but that's just super important. Battery starters and circuits, you know, here you got an electrolyte, which is an acid. You know, 7 is water, which is right in the middle. When you go down on that scale, you're going acid. When you're going up, you're going alkaline. Either kind of imbalance will be an electrolyte that cause, because you got alkaline batteries and you got acid batteries. Well, the sulfuric acid that's in a car battery is the electrolyte. And each cell, it's got 6 cells. It's got around about 2 volts per cell. And so there's the storage battery consists of alternate plates of lead and lead dioxide, and it's filled with a sulfuric acid solution. And I just sort of made a little graphic of it right here. I drew this picture here, and that's how that works. You know, you got your cathode, your anode, and your battery acid in between there. Well, batteries, when a battery's charged, all the electrons are trapped on the anode side of each cell and are constantly looking for a path to the cathode side. Now, this is according to electron theory. Conventional theory has it going the other way, but for our purposes, we'll talk about that. Excuse me. All right. Before you do any kind of troubleshooting, you need to know the health of the battery, but you also need to make sure the connections are good, or you might change parts that aren't bad. If somebody, anybody that's been around cars a long time has seen somebody that was either working in the dark or really didn't know what they were doing, that took a brand new battery that still had those plastic covers on the terminals and assigned them where they drove the battery terminal down over the plastic thing and didn't have any connection at all. It's kind of funny how when somebody does that, they can't figure out why it won't start when they've made, total voltage drop between the terminal and the post on the battery and all that. But if you're not used to what you're looking at, or if you're working, like I say, my cousin one time working at night in the rain actually did that. He was swapping out a battery and he beat that post onto that, and that plastic thing was in between there. But you don't want to change parts that aren't bad, so you need to make sure that you got really good battery terminal connections. This one here, this is fairly common right here, where people will take these kind of terminals here that clamp on. There's a whole bunch of different potentials for dropping voltage here, from this crappy place where this stuff goes through here. Then they'll have a ground connected to this going off somewhere, or not a ground, but a power feed or a ground, depending on, whether you're going to power ground side of the battery. And this is what I like to do. I like to solder the terminal on there. If I'd been thinking clearly, I'd put a slide or two in here about how to do that. But there is the right way to change a battery terminal is on my channel. It's one of the earlier videos that I put out there, and I basically demonstrate that in detail on how you do that. battery terminals. Now though, this battery terminal here, this is lead right here. This battery terminal here is actually a brass, cast brass thing that's got, you know, it's anodized so that it looks like lead, but it's not lead, it's actually a brass terminal. And so you can actually turn, if it was lead you wouldn't be able to solder it worth a flip because the lead melts at a real low melting point. But anyway, I soldered that and I put heat shrink on there and, you know, clean that terminal up real good. I kind of like to put some around the base of the terminal and the battery where that corrosion likes to seep up out of the battery around to the terminal. I like to put a coat of dielectric grease around that. That's what I've always liked to do, and cleaning those terminals and making sure they're good, though that'll go a long way toward straightening the trouble out, whatever it is. Now you can get one of these battery testers for like $700, and this knob here, this knob that you're seeing here, has got a carbon pile that's attached to it, where it squeezes a bunch of carbon discs together, and it creates a load so that you can load the charging system and see how it's charging. Now if you're going to just test the battery, not the charging system, you can do your apply a 15-second load at half the cold cranking amps, and holding it at that 15 seconds, you know, at half the cold cranking amps, watch the battery voltage. It's not supposed to drop below 9.6 volts. And these things right here, this is about the cheapest one of these I could find. Sun used to make a one they called a VAT 40 that was probably the best one I've ever seen. And that one, unlike the one I'm showing you here, the more expensive ones will typically have some kind of an indication as to whether there's a problem with the stator and diodes in the alternator. I don't think this one has that function, although this one right here is fairly affordable. And it's going to measure amps and volts at the same time. Now, it's not shown in this rolled up cable business, but you're going to have, to measure amps, you're going to have an inductive pickup to go around the positive or the negative cable. If you're going around the negative cable, the arrow indicating current flow on the probe needs to be pointing away from the battery on the negative side or toward the battery on the positive side. If you're measuring what's coming right out of the alternator, you need to have it pointing away from the alternator toward the battery on the big wire that leaves the alternator. That's where I like to check it the best, because the current that's leaving the alternator is going other places besides the battery usually, and you can get a better picture of your alternator output by clamping around that big wire leaving the alternator if you can get to it. Some of the alternators now are buried to where you can't hardly get to them down there. But if you don't have the money for a carbon pile tester, you can disable the fuel and ignition systems and spin the starter for 15 seconds and watch battery voltage to see if it goes below 9.6 volts. If it does, it's time for you to get another battery for that vehicle. Now there are variables, you know, if something else is causing the engine to be hard to turn, like if some accessory is, you know, consuming energy and requiring torque to turn, or if you got a starter that's pulling too much current and that kind of thing, you may have an issue with that. But that right there, this thing right here is just really handy to have. I mean, something like this, if you're a shop. If you're not a shop, you probably don't want to spend $700 on something like this, and there are some cheaper alternatives. But the cheaper you go with your alternatives, the less information you get when it comes to troubleshooting starting systems or charging. Now, this is Sun's battery test. I learned this at Mazda school. I think it was in 1983 when I went to Mazda school down in Jacksonville, Florida. And what they were basically saying you can see how this is laid out. You're going to take a piece of wire and you're going to, what I would do is strip both ends of a short piece of wire. And you need to dip the copper into the water in each bag if you can get the top off there. Some of them you can't even get to the cells to see the electrolyte solution. But you dip it, don't touch the plates, just dip it into the water. Now I used to basically take a coat hanger and make something so that you could just set it down there and it would not touch, it would not go into the water. Don't dip your probes in there because you'll get those all chalked up and corroded and everything. So use a piece of wire that's disposable, and you're basically gonna, you can see how I've got these things hooked up right here. Your first thing you're gonna do is you'll measure from the positive post into the water. and you're going to then measure from that cell to that one, and then that one to that one. See how you're going positive post here, and then you're going to go here, take a reading, and you're going to go here, take another reading. See, you're actually going from one cell to the next. Take another reading, and you go all the way. Now this reading and this reading, you got to add those together to get the the final reading, because you're going to see a little small reading on one side of this and a reading that's bigger on the other side. But when you add those together, all of those ought to be about 2 volts. Now you're supposed to do this not when the battery is just sitting there, but you're supposed to do it each time with the battery on charge. Put it on high charge, take your measurement, turn off the battery charger, move to the next one, or have an assistant do it, or in your eye protection, obviously. You're also supposed to do the same test with it loaded at half the cold cranking amps. See, so once you've done all that, I usually just did it with the charging part of it, and it's not supposed to vary between, more than 1/10 of a volt from one cell to the other. And a lot of times what you'll find is they'll all be right around 2 volts, but one of them will be like 1.6 or something like that. That seems like, well, is that anything I need to worry about? Well, and it was one of the things that when I was at the dealership, if I was going to replace a battery, and I was going to tell the shop foreman, this is why I'm going to replace this battery, like if he had a question, I would do this test and I would show him the results of this test. Now, most people aren't going to go to the trouble to test a battery like this, but when I was teaching automotive at the college, I taught my students to do this kind of test, and it's really, really good. So every cell, whenever you add the last 2 together, you're going to have all 6 of your readings, and that way you'll be able to tell if it's more than 1/10 of a volt variance between cells. And you'll see, you can find a bad cell that way. You can also use the little squeeze bulb thing. It pulls the electrolyte up and floats the balls. You can do that. And another thing you can do is a refractometer. If you know what that is, you can look that up. Refractometer is for checking antifreeze. You can also check battery electrolyte with that. And you can put a drop on there and look through the light and look at the scale, and that's pretty handy to do too. But there's a whole bunch of different ways you can check a battery. You can also even check the temperature if you've got a good temperature gun while you're putting it on a fairly high charge. Another test is, and I mentioned this I think last week, if you put this thing on high charge for like 3 or 4 minutes and you've got your voltmeter connected to the post while you're charging it, some chargers will have a meter on them. If it goes above 15.6 at any time during that charging, if the battery, the more current it pushes in there, if it goes above 15.6 volts, that means the battery is sulfated and needs to be replaced. That means the plates have become coated with sulfur and it's hard for the electrons to pass through it. So it takes more pressure. Voltage is pressure. Current is how much is flowing. Now this is a cold cranking amp testing devices. You can buy every single one of these and a bunch of other ones similar to them on Amazon. And anybody that's serious about keeping their car maintained and checking it regularly should have one of these on hand. It doesn't cost that much. You can buy one. I ordered this one here because it actually has a graphing function that I really, really like. I didn't look too deeply into the other ones of these, but I got one of these coming, and I'll probably do a little feature video on it to show you how it is. But this one here is only $25, and it just basically gives you numbers. But I like this one here because I kind of like looking at a live graph, or a histogram, if you want to call it, that's measuring voltage over time. And so measuring cold cranking amps is pretty handy. And like I was talking about, when you start out on a battery, like say it's got 700 cold cranking amps, if you use it for a year in your car and you test it next winter, you're probably going to see 550 or 500 cold cranking amps, and then every year after that the battery loses cold cranking amps. It's almost like a gas tank, and the cold cranking amps are slowly being used out of it. Even if it's charged perfectly all the time and your alternator's working right and everything else, your cold cranking amps, any battery, I don't care what battery it is, I don't care if it's in a hybrid, an EV, or if it's the battery they store solar panel energy, all those batteries only take so many charges before they die. The little batteries that you buy at Walmart and places that are rechargeable AA's and all that. You can only charge them so many times, and after a while they get to where they just don't hold the charge very well anymore. But get you one of these if you have the money to do it and you're so inclined and you're a good do-it-yourself guy, or heck, I wouldn't mind having this one in my tool. Now I've got another one over here, this Autel one I was talking about, that I need to demonstrate one of these days, because it not only does it check charging systems and it'll walk you through it and give you charging system waveforms and all that kind of thing, but this thing, that doggone thing has actually got a graphing meter on it and all this, and it's a scan tool. It does amazing things. Now if you buy it in the accessories, you're going to spend nearly $1,000 on it. But one of these right here will do everything you need to do as far as checking cold cranking amps on your battery. Now watch this.
Positive post and the negative post. I've got about 10.3 there. This battery's not all that strong, but it'll do more than this. The reason it's not this is because I'm dropping a big bunch of voltage right here between that post and its terminal. So over here, I'm not dropping any. I'm dropping about 1/100 of a volt, which is really good. And we can also check the voltage drop between here and the starter by going here and all.
Here's your voltage drop testing. That's the first part of it. You're allowed to have up to 1/10 of a volt of drop on the negative side. Now this is with the spinning starter. You don't just check it with everything just sitting here. It has to be, current has to be flowing. You got to be spinning the starter while you're doing this test. Now you may have trouble getting down to the starter and all that, but if you want to get some good information about how much voltage is being lost, like let's say for example, you found voltage drop during this whole, between here and here, what you would need to do is, if there were other connections between, you need to basically get closer and closer together, and then you can vector in on where the problem is. Sometimes the problem will be, and I've seen it, the first time I ever saw voltage drop in my whole life was when a guy had me try to figure out why his tractor wouldn't start. He had put a brand new battery in it and the tractor wouldn't start, and I was out there checking that thing, and what I found out was this was clean and this was clean, and they were clamped together really good, but there was no power making it into the cable. So and this was a molded cable too. This wasn't one of those that you bolt together. Right in here, there was no continuity between this terminal and that battery cable, and so I took that thing off and I put it on the, something metal, part of the plow or something, and I banged it with a hammer to squish that against the wires that were inside, and I put it back on there and the tractor started. That was in like 1975. It was a long time ago when I did that, but it's the first time I ever saw voltage drop. All right, now there's other voltage drops you can do. Right here, you're not supposed to have more than 1/2 volt on the positive side. While it's spinning, you got to have it spinning, and once again, you can vector in. I've actually done voltage drop tests between here and here. I've got a video about that, and you can do voltage drop tests between here and here as well. I like to do that. Actually, I got this drawn wrong. Duh, that's not right. Scratch this. I was an idiot. This is supposed to be here. But anyway, there's other places along the line. If you got other places you can check, you can see if you've got bad voltage drop. Like if you've got, let's say if you had 8 volts here that you were dropping, that means you're only getting 4 volts down here. Forget about this. I can't believe I do that like that. What a dummy. I wasn't thinking clearly or something. You got to go from that post to that terminal. Go right to the terminal now. If you go here, you may get bad. You may miss some voltage drop that's between here and here. But what I like to do also is I like to go from here and into that wire, kind of like I was talking about earlier. See that? Okay. Now, the alternator charging system voltage drop you can do like this. I should have probably put those slides off until next week, and you can also do a ground voltage drop. You don't usually see that because the alternator's voltage, the brackets is bolted to the engine, but there's a remote possibility you could have issues about that. Anyway, man, I feel like silly for drawing that thing wrong. Once again, the charging system voltage drop, the voltage drop for your, is supposed to go to here. But what I also said, I have gone between here and here before too. And if you wanted to, like for example, if you went from, let me erase some of that. Let's say you went from here, let me go ahead and draw a black line, to here, and you found some voltage drop. But if you go, let's say that when you went from there to there, you wound up with, can't even draw a 3 volts. 3, there you go, that's 3 volts there, right? Well, then you still wouldn't know if the problem was between here and here, or between here and here, or maybe at this terminal here. So what you need to do is you would need to take this one and you need to move it to here, and you would need to record that. And if you had like 0.1, 3 there instead of 3 volts, like a little bit, then you would know the problem was inside here, between these two. The big copper washer that slaps in. Let's talk about them starters for a second. The current flowing through the brushes and the commutator into the armature creates magnetic fields that push against the permanent magnet so that it spins the armature. And permanent magnets have only been the order of things when they started making starters smaller and cheaper. The windings that went around the field coils were all wired in series with the commutator and everything, and so you created these big shoes that had wire wrapped around them. I could have put a diagram of that, but what's the point? And so you had a magnet, you had electromagnets around the outside, and that caused the older starters to work. But these permanent magnets, or what's in power window motors and all kinds of other stuff now, permanent magnets are very easy to do. I did have a fan that had permanent magnets in it that had been built wrong, and I got a video on here about that, about how when we put it in there, the fan was messed up, the old one, and making noise, and we put a new fan in there, and it made a lot of noise, but it didn't move any air, and we pulled it out and tested it on the bench, and it was spinning backwards. It was built wrong, and we had another fan, but they put the magnets in there the wrong way, because you now notice your north and your south, see how they're reversed on that thing. These magnets will have a kind of a curved look to them. The starter contactor is that's what best way I can describe that thing as a contactor is you notice how this washer right here, let me get a different colored pen, this washer right here, I need to get a red one, smacks against these two terminals here, and that creates the connection that takes battery power into the starter. Alright, and you notice on this one down here, this has moved, and it has actually, the core of this solenoid has smacked back, and it has slapped that washer against these two posts, but before it ever did that, it put this gear in mesh with the flywheel. So this gear meshes with the flywheel before this starter ever starts spinning. Now, I put a starter on my Taurus one time because it was worn out, and usually you can just take a starter apart and put brushes in it, and that's all it needs, but my starter on my 07 Taurus was worn out and quit working, and so I put another starter on it, and it worked just fine for a couple of days. And then, lo and behold, I was going to try to crank up and go home one night after I was leaving work, and it sounded like the starter started spinning before the starter drive ever entered the teeth on the flywheel. So as soon as you turn the key, you'd hear the thing chatter against the flywheel. And I was thinking, man, if I do that many more times, I'm going to have to put a flywheel in this thing. And so I had to shut everything down for the night, ride home with somebody else, come back the next day and swap out the starter again. I don't even know how that was physically possible for the starter drive to start spinning before it ever went into the flywheel, just based on the way that it's designed, with the way this lever throws that forward before this ever makes contact. Anyway, battery starters and circuits, whenever you're looking into one that you're spinning over and you're trying to figure out why it won't start or whatever, you need to make sure that you know how it's wired up so you'll know what to check. You know, this is a real simple one here. It's going to go through a clutch switch typically if you've got a manual transmission, or through this neutral safety switch. You might notice that this only will carry power to the starter in park or neutral. If you're in any other gear, then you do that. One time, this is a crazy story. Back in 1985, I was working at the Ford dealership, and there was a Ford pickup in there, an old 71 model Ford pickup, and the backup lights didn't work. Okay, the backup lights are part of this same switch assembly that was down there on the side of the transmission. And so this is how goofy I was. I said, well, I'll disconnect the wires going down to, and I had to climb up in the engine compartment with my rear end up in the air and reach down there and unplug the wires going to the neutral safety switch / backup light switch. So I unplugged that wire, and I got the harness in my hand, and the neutral safety switch is disconnected. And see, I had already put it in reverse to see if the backup lights would come on. It was still in reverse. And I said, well, the backup lights didn't come on. Well, let me go ahead and just unplug this, and I'll go ahead and bypass this circuit here at this connector and see if the lights come on. That way I'll know it's a neutral safety switch. Well, what happened then was I was fooling around in there. Like, you got a hot wire that's supposed to feed your neutral safety switch. I managed to find the wire going to the starter in that same connector, and the engine started with me under the hood and the truck in reverse, and it started backing up. That was one of the stupidest things I ever did. You know, how many times does an instructor tell you about stupid things they ever did? But anyway, this other mechanic, who was a transmission mechanic, was a pretty quick thinking guy. He ran over there real quick and jerked some coil wire off, and plug wires or whatever, kind of tore up some plug wires, but he shut the thing down. And there was a bunch of new cars behind me over there being pre-delivered. That would have been a real disaster. I probably hadn't been working at that dealership but a couple of months at the time. But it was one of those times when you just aren't thinking as clearly as you should. You aren't thinking ahead. If the truck's in reverse, I'm under the hood, the key's switched on, I'm fooling around in this connector where there's a starter circuit and there's power, and if you jump the wrong thing, you can see how that would have been an epic disaster. I probably never, wouldn't have had a job after that, but that guy. Okay, well, enough about those stories. This right here, if you usually have a starter relay on the ones that have anti-theft, or on a lot of the vehicles today, you might have, on a lot of newer vehicles, you'll have a push button start that has a relay that, is energized because it's told to by the modules of the computer or whatever. You also, like on some of these late model Chevy pickups, you just touch the key. You don't even have to hold it until it starts. You just bump it to the start position, and it automatically spins the starter until the engine starts, and then it releases the starter. Some of these relays that I've run into are actually built into the smart junction box or the fuse panel, so that you cannot replace the relay. You have to replace the whole panel. And so anyway, like for example, if you see the relay drawn and it doesn't have these numbers telling you which terminal is which, then that's probably going to be one that's built into the panel. And so, but if you got to factor in everything that can prevent it from starting. In this case, you don't have a whole lot of choices. It's just, you just got what you see is what you get. On here, you got to find out, is the PCM in a neutral safety switch? Is this a good circuit? Is the relay good? And so on and so forth. I mean, there's all kinds of stuff you need to check, and there's lots of places you can check for voltage drop and everything. If you hear the relay click but the starter doesn't engage, you're going to have to do some voltage drop testing there. And what I would do is take my meter here, and I would go from here, and I would go down here, and I would see if you read 12 volts, even though you hear the thing click, you're dropping some voltage somewhere in here, so on and so forth. I could probably go on for a while about this. All right, learn how the system's wired up and how it works. Is there a fuse involved? How is the vehicle equipped? What about aftermarket devices? What does somebody put on there? Occasionally you may run into one. I had one time that I think I talked about earlier, where the service writer, whenever I drew the ticket, one of the repair lines said you had to turn on the left turn signal before the starter would work. And I thought, that's the craziest thing I've ever seen. And I dug into that thing for about 30 minutes before I found out that the customer had deliberately rewired it that way. And I went and asked, and this was a warranty ticket. And I went and asked the service writer, why didn't you tell me that the guy had this thing wired this way? And he says, well, I just wanted you to make sure you knew how to start it. And I said, well, why did you put that on a repair line? You know how much time I wasted out there looking for this? And should have put it on a sticky note or just called me up there and said, hey, you got to turn on the left turn signal before you can start the truck. They had that as the personal anti-theft thing. Who's going to think about turning on the left turn signal to get the vehicle started, you know? That's pretty slick. Now this is a starter, this is a test, a bench test. And a bench test is always a good idea. We gotta get our focus done. See, that starter is completely dead. It's totally useless. Sometimes you'll see them spinning really slow. And sometimes, you know, you can tell if you've got a good strong battery that you're testing with. You can't do this with a battery charger. You need to do it with a battery or some other really strong power source, but there typically needs to be a battery involved or you won't get a good test out of this. All right, you need to look carefully when you, this woman here, she had a starter that was replaced on her Chrysler, and she said, I had to tap the starter before it would start, and, wait a minute, and she says, and this one here, you might have noticed.
Starter drive, overrunning clutches, no good. It has to catch just right.
I advanced my slide too quickly. And when I'm recording one of these, I can't go backwards. But you might have noticed if you want to back up and pause that thing, you can look at the starter. That little screw is where the brushes got their ground, and it was left loose when the starter was rebuilt, and you can see it arcing around there. I used to see Power Stroke diesel trucks come in there with those $700 Mitsubishi starters on them, or whatever kind of Japanese starter they had, and they would not start. And I'd get under the truck out there on the service lot with a flashlight, and I could see that there was scorching around one of those screws on the back of the starter, and all I had to do was loosen that screw a little bit, brush that off really good, tighten it up, and that starter was completely fixed. Because those screws would work a little bit loose. The brushes are getting the ground through the cap on the back of the starter. If the screw's not tight, it won't be grounded good, and that's more common than you know. Well, the next time we're going to talk about alternators and charging, and I want you guys to have a great week and be really careful out there. And I'll see you next time.